I'm at Amoroso from Tag Cyber, and I'm here today with Stuart Wilson, who's the CEO of Endace, and talking to us from New Zealand. It's very nice to see you, Stu. How are you?
Yeah, good morning, Ed. I guess it's afternoon over there, but yeah, pleasure to talk to you.
Hey, as a network engineer my whole life, I've been waiting all day for this because I love the technology you guys have, and I'm looking so much forward to the discussion here. But to start, for people who may not know the company, why don't you just give us a quick summary of what you do, and then we can get into some of the technology discussion.
Uh, it's pretty easy to describe. I think Ann Nurnberger recently said, if you can't see a network, you can't defend a network. And there's a range of analytics tools in the market to be able to do that. I guess we take it one step further and we say if you can't remember what happened in a network, then you can't investigate the problems that happen there. So our job is to give networks a memory to allow investigators to go back, 1, 2, 3, 4 or more months to get an absolutely accurate rendition of exactly what happened so they can solve problems.
I mean, it's a massive recording, right? I mean, is that in a
Yes.
sense what you're building? It's
Yeah.
amazing. I love the
Yeah.
idea.
It's massive recording, and people often mistake it for standard storage. And and, but of course, in order to do it properly, it is storage, but it's very specialized storage if you want to do it really well and make it work for the analysts.
Well, we'll get into that because you guys can unravel weird stuff. Like for years, I could never figure out when there were odd connection problems and so on, asymmetries, and you
Yep.
guys saw that. But let me take you way back. How did you get into like what was the original concept? Were you guys doing DPI or something? What was the original impetus for the company?
So it sprang out of the University of Waikato here in New Zealand. That's why we're based here. You know, people often ask why you're based where you are. Well, that's usually where it started. And the researchers there were looking, it was very early internet days. Actually, it's our 20th anniversary this year. So, we're a very, very established startup, if you want to call it that. Sprang out of the University of Waikato. They're doing research, very early research into internet stability back in the days of very early days when that was a real problem. And they couldn't afford the HP equipment to capture internet traffic. So they built their own. And then they discovered that there was a whole raft of customers who wanted to get access to exactly bit by bit what was happening on the networks. And so back then, the customers were, the agencies, the telcos, and some of the really large banks were the customers. And it's evolved from there. About 12 years ago, actually close to 14 years ago, we introduced our systems product, our probe, to allow end customers like the operators to take a full system in rather than components and build their own. And that product now is our mainstay, and people are deploying literally thousands of our probes into a single system to be able to monitor their global networks.
Stu, was cybersecurity one of the use cases back then? I mean, I'm part of that buying community back in 2001. And I seem to remember not as much around security as different kinds of forensic around performance and other things. But what was the role of security back then? And we all know it's important now.
Well, back then, because, it originally was an OEM product, so people would build it into whatever system they were interested in. I know AT&T was a customer of ours, and they were interested in what was happening in their network from an operations point of view, but also from a security point of view as well. The intelligence agencies, of course, we were never sure exactly what they were doing, but pretty sure it was around cyber. And of course, the banks and the telcos were very interested in network performance. So back then, a range of activities, and that still continues today. People still use this network memory, this network evidence, to solve a range of security and network operational problems.
So I think I know the answer, but I'm going to ask a question that I think a lot of people might be wondering. You and I both know that when you say network, my mind, a lot of minds go to the 7-layer stack. Like we all read the OSI book by Tannenbaum 20 years ago. But so when you say network, are you are you collecting just at the packet level, or are you providing context, or is like where are you tuning, and how do I put these things together? Because it's hard to make sense out of a bunch of packets. How do you guys do that?
It is very difficult. Actually, a lot of analytics packets take the real-time data and they scrunch it down straight away into high-level metadata. The issue with that is if you're trying to get to the root cause of a problem, metadata is very efficient, it's very compact, it tells you a lot of information, allows you to search for user information very quickly, but of course you lose a lot of the detail. We capture at what we call layer 2, which is at the Ethernet layer. We're essentially capturing every single bit off the wire. And then we take it in and we analyze the protocol stack, and we attribute protocol stacks, protocol attribution to each of the flows, and we put a lot of that information into a huge database so that when you go to search for information, it's very rich. You've got layer 2 tunneling protocols like MPLS or VPN. You've got protocol types, whether it's Facebook or whether it's FTP. All that's in this big database, but the actual packet data that we capture is a bit for bit accurate rendition of exactly what happened on the wire. And when you look at some of the really nefarious exfiltration attempts by nation-state exfiltration attempts, you really need to get down to that bit level to solve the problems. So we both generate metadata so we can index, but we capture the actual packet data, the actual bits that traverse the wire, because investigators need to get to the absolute truth when it comes down to it.
So, and I'm trying to play through my mind questions that people watching might be asking. But one would be that networks are complicated. It's a massive topology that usually, you and I know, a typical enterprise, maybe there's not even anybody who understands that. So when I do this I think we're deploying probes, right? They call it Endace probes that I would put into the network. When I'm collecting all this, do I then, if I'm trying to make sense of something, do I have to have some way to put it all sort of back together? And how does that work? Like, how do you do the analytics on top of some of this stuff? Give maybe a little insight into that analysis work that you do once I've captured all this data.
Yeah, so the way we do analytics, the way we do what we call investigation is very unique as well. Typically, an analytics package will immediately analyze the data and structure it into metadata and stick it into a database. And you can't change the way you look at the data. Because we capture a range of information and stick it into a generic database, we can change the way you slice and dice the way you look at the network information at the end. And you can either use an API to get direct access to the packet data, or we do have a way to visualize the traffic that's happening on the network. And we can resolve issues that are as small as a microsecond, actually graphically render that, all the way up to as long periods of time, like a month. So being able to see that traffic data and being able to filter down on the MPLS or the VLAN tag or the IP address pair, or allows you to zero in on any strange network behavior that may be happening. Some of our customers use that investigation tool without even going to the packets to investigate strange protocol behavior in their networks. So there's a variety of tools in there. You don't always have to go to packet data. We have investigation tools that let you do that. Now, if you want to look for much more complicated events in your network, there's a range. There's hundreds or thousands of analytics companies out there. You just have to go to RSA when it's running to see the hundreds of companies, and they all do a very slightly different security take. Some do classic IDS, some will do IPS, some do AI, some do machine learning. Everyone's got a slightly different take for a slightly different problem. So the way we handle that is we're able to host these third-party analytics on our probe as well, and we're able to run that real-time packet data into their analytics so that their analytics can find issues on the fly. But we do one more very unique thing which nobody else does, and that we can replay old packet data. It could be 2 or 3 months old. We can replay that into analytics to look for zero-day threats with brand new rules. So we've got these very unique ways of extending the capability of what we do. You know, in the security space, everyone recognizes that partnerships work, and trying to do it all yourself doesn't. So we have a very rich partner program to allow us to extend our probe using other people's analytics capabilities.
Stu, I want to play that back. Sorry for the pun, but to make sure that watching understand that point, because that is key. You could take, for example, let's say Palo Alto Networks. I know they're one of your partners. If they're running and they do IDS as part of their next generation platform, let's say they're not picking something up at 0 day, they're not seeing it for whatever reason. I think what you're suggesting, and this is really awesome, you could go back with the data when they do come out with a signature or come out with some behavioral technique to recognize the problem, maybe ML based, and demonstrate that they can pick it up on the data after they've, or demonstrate that they can. I mean, but that seems to me like something new. I always feel like we've seen everything. That is a really cool concept. Am I reading that right?
Yeah, that's really correct. It's correct. It kind of goes back to Anne Nürnberger's comment, you know, but you don't want to just see what happens on the network. You want to be able to see old traffic.
And she's the cyber czar in the United States as of a couple months ago.
Yeah, she's with the White House now. So she got it absolutely right. It is a unique capability. Often you don't understand the signature of a threat for maybe 1 or 2 weeks until somebody figures it out, some analyst figures it out. By that stage, you don't know how much damage that particular threat has done because you haven't been able to recognize it in your network because there has been no signature up until that point. So the ability to replay old traffic past a new signature allows you to understand much in absolute detail whether that particular threat has been in your network for that 0 day time, for those 2 weeks where you didn't understand that threat. So it's a very unique way of, it doesn't stop the threat, but it gives you a very accurate rendition of just how much damage has been done. And I guess SolarWinds is a great example of that. It was in the network for quite some time until people understood how it worked. And in fact, one of our very large US government customers, we can't say who, has been using our system in order to investigate just how far the SolarWinds breach went using old traffic. So it's a very unique capability.
You know, Stu, you and I both know that in the early days, packet inspection was kind of ad hoc. Had a lot of weird tools, sometimes pretty expensive ones, big giant. I know I used to buy them, and it wasn't a great experience. But from what your team has shown, I remember months ago you guys showed me a couple of live demos, and I think it seems like you guys have solved those. And I'm wondering, I know this might just sound like I'm tossing you a softball here, but is there any reason why people would not do this? I mean, I guess everything costs money, but it seems like this is a must-have. Am I missing something? It really seems like
no. I think it's a classic maturation of a market. In the past, packet capture has been something that engineers cobble together. I mean, anybody can do packet capture. You can take a standard, take a standard computer and a standard net card, and you can capture packets and write them to disk. But the performance is limited, and it's very expensive, and you know it stops working, and it's very difficult to manage hundreds of those kind of ad hoc devices in a single network. So it's not what we call enterprise class. So what we've done at Endace is we've focused not just on the function of packet capture, but we make it run really fast. We can capture very high data rates. We can capture very deep storage, which allows us to look further into the past. But other things that people really care about in an operational environment, like reliability, you know, the fact that all the probes stay up, scalability, you know, the ability to run literally thousands of these probes in what appears to be a single network. You can issue a single search command to thousands of probes. That operational scalability and reliability is the critical part of turning it into a really functional system. And of course, it has to be cost effective. It's a very specialized form of storage. And as a result, the way we do it, we're probably an order of magnitude cheaper than generic storage. But the problem with generic storage is it has to serve a bunch of masters. The way we do it is it's very specialized. So not just reliable, not just fast, not just scalable, but very cost effective as well. And that really is the breakthrough that makes it usable by organizations.
Stu, is there a whole methodology for where you place the probes? I would imagine I'd rather be dipping my ladle into clear text than encrypted. You probably want to spread it into like in choke points or places where there's likely to be the most interesting traffic. Like maybe, is it sort of like where you would put something like a Palo Alto, then I'd put one of these? Give us a little feel for the methodology for deployment. What's that? What that's like?
Yeah, so first of all, we're not placed on public networks. Public networks involve, so that's a whole different ballgame. That's lawful intercept. That's not where we play. We play on networks that the operation owns, and they own the data. So they usually put it near a peering point, or they'll put it in a part of their network which is especially sensitive. They're very worried about infrastructure being exfiltrated or attacked. So they'll put it in a variety of places, but the peering points is a very common place to put it. With regards to encryption, we have partners which, such as Exia and Gigamon and others, and they will do decryption and then pass it on to us. A lot of customers don't run encryption everywhere. The reason they do that is that you can't, once again, you can't defend a network that you can't actually see. Problem with encrypting internal networks is you can't see the bad guys either. So, so when we see encryption being used in enterprises, it's usually on the outside. So, so we'll see it deployed mainly at the peering points and in very sensitive parts of the infrastructure. Some of our customers locate our probes in remote locations. They have, maybe hundreds of remote locations around the world. One of our largest bank customers does exactly that. And they'll place one of our probes at every single one of their data centers around the world. So there's a variety of deployment methods.
I've spent a lifetime with big monster networks and peering points, and I agree, collecting at those natural sort of connection points, that's always been the best place. You can count packets, you can look at protocols, really cool. The trend now, though, and now maybe I'm going to ask you for some predictions. The trend is more toward a massive separation of control and data planes into like this cloud-based concept. I think one analyst group calls it SASE, like Secure Access Service Edge, where everything's cloud-based. There's no more hub and spoke. MPLS goes away. Seems like big changes to me. I know that peering points will remain at least for the big tier companies, but for banks and so on, their architecture's changing. When they come to you and say, hey, what will be, how are we going to capture history as the network shifts to cloud-based? Is it a natural progression for you guys, or is there some re-engineering that you'll have to do with changes in future networks?
It is a natural progression. There's actually a few parts of that discussion which I'd like to unpick. First of all, we don't see all of our customers going to a cloud architecture. There's a very large, it's a very large bank customer of ours, and that during COVID they've actually decided to stand up their own data centers around the world. And they're putting a lot of small data centers around the world locally in order to improve performance, and it becomes completely touchless banking. And so we're actually seeing them deploy one of our probes in every single one of these micro centers. But a lot of customers are going to hybrid cloud. The one thing we do see is our target customers are anyone that has really serious data governance concerns. Banks, medical insurance, hospitals, military, anyone who has really sensitive data. We see them putting some services in the cloud, but not all. And the reason for that, of course, is that you can hand off the operation to a third-party provider, but you can't hand off the responsibility or the governance to another provider. So they still keep their crown jewels under their own control. And that's a classic customer that we would sell to. They run their own infrastructure, often global, often very large. We call them the Fortune 2000. That's pretty much our target for the high end. Now they are doing some cloud work, and we're working on cloud versions of our product. Very interesting. The difference though is that our normal product is hardware that the customer puts in the ground, and we have to put all the capacity in to start with. So our cloud product is looking much more like a very flexible, dynamic, elastic, on-demand product. So our CTO is working on that right now for deployment, because most of our customers like hybrid. They want to be able to see both their established infrastructure and their cloud infrastructures with one lens. So it's very much in our future. But we actually think that a lot of established infrastructure is owned by companies that's not all going to go away. People have got huge investments in current infrastructure, and yes, there is a large movement to cloud, but if you think in terms of where the really sensitive data is, that's going to stay on-prem for quite some time, I think.
Well, I have a feeling that the capability your CTO is working on is going to be that's going to be a big piece of your future. That's very exciting.
Yeah.
You know, Stu, I'll tell you, this is an area that I think people underestimate how absolutely fundamental it is to have visibility to the network. It's I'm so glad you guys have been doing this work. Happy 20 years. By the way, I've heard a joke before that after 20 years, somebody gets really, really popular and they say, it took us only 20 years to become an overnight success.
Yep.
So, that's probably what you guys are experiencing, because I know you're doing lots of business now, and I couldn't be happier. It's good stuff.
Yeah, it's interesting. As a company, it takes a while to find your feet, and we're really secure in the direction we're heading now. Yes, we've seen a lot of different parts of the market, and we're really secure. We see our customers using our gear and getting great value out of it, and that's really what drives us and what tells us that we're on the right path. So it's just a matter of the problem now is hanging on as we expand. So it's fun to see your ideas take off.
That's great. Now, for people who might have some interest in learning more, is the website the best place to go to get maybe a briefing or a demo?
Yeah, website's definitely the best place. www.endace.com, endace.com. Definitely the right place, and that'll put you in touch to get a demo. Talk to our salespeople. We're a very approachable company. We really believe in close relationships with our customers. So don't be scared. It's a good place to go.
If somebody buys in the US, can they come do their training in New Zealand?
Just right now you can come, but it's 2 weeks quarantine.
That'll go away. Well, pretty soon, trip to New Zealand sounds pretty good. That's probably a nice sales.
Trip to New Zealand, if you like fishing and skiing and outdoor hiking and drinking wine and eating good food, then I guess it's not a bad place.
That stuff doesn't sound so bad to me.
That's not so bad.
Listen, on behalf of our team at Tag Cyber, thank you so much for spending time here. I love listening, and I wish you nothing but the best with your customers and with your team.
Yeah, and thanks very much for your time, Ed. It's great talking to you. Thank you very much.
And for the rest of you watching, we'll see you next time.